Hello everyone. Again we are here now learning about time of flight, the second important term in oblique projectile or nothing but like projectile motion only. So the definition first immediately let me write. So time of flight is nothing but the total time taken or the time taken for the projectile to remain in air. That's it. Okay. The time taken by projectile to remain in air. That's it. So simply if you want to say how much time, for what time the projectile is staying in the air, that is nothing but your time of a flight. So let me draw a diagram so that easily we can understand the thing, so that we can derive the thing directly. So see here, say this is along x-axis and we are also having the motion of the projectile, that is path a particle along y-axis, right? So therefore it is being projected with some velocity u, so it is taking this projectile motion. So path nothing but parabola, path is nothing but parabola. So therefore this is some initial velocity u and it is making an angle theta directly. So this is y-axis and this is x-axis. See now, as the particle is moving along this projectile, I mean this parabola. So if you just consider the position of this particle, see here at whenever it is this, so you can see in this way it is at this position here. So when the particle you consider here, the position along y-axis will be straight away, the coordinate will be here, and again when it is over here, so you can just directly say it is the maximum position, so it is here. And again when it is coming down, you see here when the particle is over here. So now what you can observe, the position of this particle which was giving its impression on the y-axis is now again decreasing. See at this point it is coming back again almost to the origin, right? So what you can understand, as this particle is moving in this parabolic path, that is nothing but projectile motion, the displacement of the particle along y-axis, see here, first initial it moves up and then again it is coming down, so back to its initial position. So therefore we can confirm that displacement of the particle, displacement of particle, who is that particle? Projectile, projectile along y-axis, along y-axis for a time, for a time t is equals to time of flight is 0. So what is the displacement of projectile along y-axis? We consider that is y, which is nothing but 0. And now let us take this one directly. So we have, right, from second equation of motion we have written that y is equals to uy t plus half ay t square. This one already we know, so substitute. 0 is equals to u sine theta into t, that is your time of flight, minus half into g into t square, half into g into t square. So directly you will get it as half g t square is equals to u sine theta into t. So 1t can be cancelled, sending this 2 and g that side, you will get total time of flight as 2u sine theta by g. So this is the total time for which the projectile remains in the air. And as usual, you know, u is velocity of projection, theta is angle of projection, and g is your acceleration due to gravity. Hope you understood. Thank you all.